It's a nice October afternoon here in the workshop, and I thought I would make a few improvements to the Studebaker since I've got a chance to drive it, mainly to the front end and maybe a little engine work. So I'm going to get started on this and see where it takes us. I spent so long building this thing, it was actually 5 years I worked on this thing, that a couple things slipped my mind during the process. That is one, that I don't have any caster in the spindles. I need about 8 degrees. The top of the spindle tilted towards the back, positive caster. 6 to 8 degrees is what I would like to have, and there's 0, so when I get up over 40 miles an hour, this thing's all over the road. I have some toe in it, but that doesn't seem to help. I have these spindles made by Mark up at Renegade. They have KPI, kingpin inclination, and this is how they would be oriented on the axle. I'm going to have to move these higher up on the spindle, I'm pretty sure. We'll see. I'm going to remove this axle and then get it on a table and lay it all out. Make sure it's set up before I cut and weld anything. Alright, so I have the axle removed, and if it goes according to plan, the spring won't move and neither will the tie rods. There might have to be a little adjustment here, maybe to this opening, but we'll keep the spring where it is, and I basically need to cut these off, install the new ones at the right angle, and then repaint it. Alright, let's set up to do that. We just returned a couple of days ago from the 24-hour race down in Wilcox at the Pillsbury Winery. It was also the AZ200, which is how many laps you can do in 200 minutes. And of course, how many laps you can do in a 24-hour period. These are the stickers that we've got for the monocar and the Porsche Experimental. Here's the monocar in all its filthy splendor. I think I got in 19 or 20 laps. Maybe it was 23. And then here's the Porsche Experimental. We bent the axle. I don't know if you can see how far that's leaning. Way too far. Of course, it's filthy too. Between Kendall drove this and I drove the monocar. I think we drove about 60 miles So we had a good time. We didn't take the Studebaker because I don't want to get it this dirty. And it's pretty rough on the cars down there. So no breakdowns with the exception of that bent axle. Okay, back to the Studebaker. I picked up some poster board and taped two pieces together that I can use to lay out the geometry of these new spindle locations. Here I've removed the old spindle, and this is the part I'll cut off. It's a shame, I like these spindles. See, they have this little thing that captures the head of the bolt, which is nice. But they don't have the kingpin inclination, which really does make the cycle cart handle much better. I've driven Steve Vincent's car and he has those spindles, so I'm convinced and I'm going to change over. So onward with the layout. Here I have a few layout lines that help me establish what's going on with the axle right now. Then once I cut these old spindle brackets off, I can align the axle with the layout and start figuring out how to graft in the other spindles. My plan is to use the metal cutting bandsaw to slice off these old spindle brackets. I think it's going to work okay. Just have to take my time and be accurate. Well, that turned out pretty good. With my angle grinder, I cleaned up the ends of the axle, and I also worked on the layout a little bit. This line represents the exact end of the axle. It's centered equally on this layout. This center line here represents the existing axle. Here it is with 30 degrees of positive. See where the wheel tilts out at the top? That's what would happen here. This line represents the tie rod connection. So I'm going to superimpose the spindle over this drawing and see what happens. So if the spindle was just welded on, you could see how the axle would not be in the correct location. So to get the kingpin inclination, I would line up the axle. Okay, and you can see that it doesn't work very well. I need to move the spindle up to get it where it can be welded in here. So that will effectively raise the axle, which lowers the front end. That looks to be about an inch. The tie rod connection is not in the correct location either. It has to move up. So if this was up here, I'd be in better shape. Here you can see the new layout. This fits right over there, like so. So that's where I'll cut the axle. Same thing over here. And I went with, I didn't go with the 3 degrees, I just kept it straight, 0. I made the cuts, and this side fits really nice. This side, need to grind a little bit right here. It's just not there yet. When I line this up, it's a bit of a gap right there. So a little work and I'll have that where I need it to be. I've been working on the setup to weld these spindles. I leveled out the axle. I cleaned up the metal wherever the welds are going to be. I used this gauge here. It's set at about 8 degrees. That's the top of the spindle, tilted back, positive caster. I also have this set up to do a little practice welding. I don't weld that often, so I gotta do a refresher course. All tacked up and looking good. I finished welding everything off. It's still hot, but I'm happy with the results. I think it'll work just fine. I'm in the mock-up phase now. I've loosely installed the axle and I'm going to slip the wheels on, get it down on the ground. Then I can check the tie rod connection. This is looking like it's going to work out okay. Here you can see the 8 degrees of caster in the spindle brackets, leaning towards the back at the top. I need to work on the height of these arms here. They need to be up at the top of the spindle. I'm missing the opening here by, oh gosh, 1.5 inches to 2 inches. I'll need to shorten these tie rods, and I threaded these originally. These are 3/8 diameter, so I can do that. Also, there appears that I may have, now that everything is settled, 1 degree of negative camber, which will actually help the handling also. Alright, so I'm moving in the right direction. Just keep plugging away. Here is the arm that I cut off of the spindle. And using this as a guide, I want this length right here. It makes for a good turning radius. I used it to create this shape. And that gets things up where it needs to be. So, looks like this is 1/4 inch material, so I think I have some. I can make this, get it welded on. I have a piece of 1/4 inch plate steel here, and I used the pattern and traced it, so I'll use the metal cutting bandsaw to chop this up, and then I might drill these holes first. Let's see. I'll get these drilled out while I can put them in the vise. I drilled a starter hole. That works. I'm making progress this evening. I finished welding this arm and the tie rod's on there. It's still too long, but you can see that once I get it the correct length, I shouldn't have any problem. Looks like it's going to work in here too. Okay, on to the other side. So you can see the string lines here. I've done this before to do a static alignment. I basically can use it to measure how much toe in or toe out I have. I'm setting it up because I need to adjust the length of these spindles. So before I can mark them and rethread them, I want to know these wheels are basically where they're going to be. I think I'll set up for an 1/8 to 1/4 inch of toe in. Upon further analysis, I've determined that I need to shorten the tie rods by 3/4 of an inch. I have this access hole here that I can get to the inside tie rod ends there with the pitman arm. So I might be able to thread them right where they are, but it's probably easier just to take them off, put them in the vise. So when I started cutting and welding on this axle, I was hoping for the best, and not bad. I can easily modify this. Seems to be working okay. This side looks good too. Actually a little bit better. Okay, so won't be long before I can test drive this, see how it works. So one of the issues I want to address is when I go to full lock, see how that overextends? I'd rather the spindle stop right about there. I still get good turning radius. Same thing on the other side. So my plan is to just add a little tab right here to hit against the spindle bracket, and that should control the steering stop. I moved the Studebaker out here so I could weld the small little tab right there. I'll just tack it for now, and then when I take this apart to clean it up and paint it, I'll shape it real nice, finish welding it off. I also have to put one right here. I removed the axle, and now I'm in the process of getting it all prepped up and repainted. I already prepped and primed the spindles. So just a few more minutes and it'll be ready to hang up. I may have to go to the paint store. I don't think I have enough paint. One good thing is I do have just enough paint and clear coat to pull this off. Alright. Okay, I finished painting and clear coating the axle and the spindles, so I can reinstall them here directly. I have it all back together now, looking pretty good. So Let's get it out and do a quick test drive. See how she runs.
Dennis Thomas in the finished Studebaker. A nice, smooth run.
Well, I have to say that the driving is vastly improved. What a difference. I can drive with one hand. It's nice and stable, very predictable, turns beautifully. So I highly recommend this upgrade. Okay, sweet. This is the first time Kendall's had a chance to drive the Studebaker, so she's liking it. Mom's turn. She didn't stop. I think we'll call it the end of this video. Thanks for watching, everybody. And I'll be posting a video on the engine